Welcome back, guys. So we are going to continue our videos on trigonometric integrals. So we have a problem here. We are asked to evaluate cosine to the fifth x sine x dx. So if you look at this problem, in my previous videos I've been talking about how you should look at the powers and what the powers are supposed to tell you. So this problem right here, we will look at our powers. Here we have an odd power of cosine, an odd power of sine, but we are interested in this because the odd power of cosine is greater than 1, and so we can apply one of the rules that we learned in our previous video. So the rule says if you see an odd power of cosine which is greater than 1, we split off one of the cosines and we substitute using the trigonometric substitution. So what we're gonna do here is we're gonna split off one of the cosines. So we're gonna have cosine to the fourth x multiplied by another cosine x, which is to the power 1, but we won't write 1, sine x dx. We know this guy here can be rewritten as cosine squared x all squared. So let's go ahead and write that. We're gonna have cosine squared x all squared multiplied by cosine x multiplied by sine of x dx. Now, if you do remember in our previous video, we have this trigonometric identity where we know that cosine squared x is equal to 1 minus sine squared x. So we're gonna substitute for cosine squared x. So we're gonna have 1 minus sine squared x all squared. We have our cosine x here, divided by sine x dx. So at this point, we will go ahead and do our u substitution. Usually we let our u be equal to what we substituted for. So basically we will let our u be equal to sine x, because we know if you do differentiate sine x, we get cosine x, and that is the rule for u substitution. If you could see the differential of one of the terms in the problem, then you go ahead and do a u substitution. So we will let u be equal to sine of x. Du will be cosine of x dx. So at this point, if you look at the u, we have the x here, we have the x there, we have cosine of x, we have cosine of x. So we can go ahead and substitute for that. So our question here has been reduced to 1 minus u for sine. So we have sine squared, will give us u squared all squared, and we have another sine here, so we have another u outside, and then we have the u which is going to be substituted for this guy and that guy because it's equal to that. So our du. Then this is just FOIL. This is basic algebra. We go ahead and open it up. We have 1 minus 2u squared plus u to the 4th u du. This is also the same as writing because we're gonna like open this one up. So we're gonna have u minus 2u to the 3rd plus u to the 5th du. So we're gonna then integrate all these guys one after the other. So if you do integrate u, we will get u squared divided by 2. If our minus sign, if you do integrate 2u to the 3rd, we have 2u to the 4th divided by 4. Plus, if you do integrate u to the 5th, we have u to the 6th divided by 6 plus c. We always add our c to it because the question is an indefinite integral. So right now we actually done solving the problem, but what we're gonna do is we substitute a u for something, and we cannot leave our answer in terms of u. So we'll go back and leave our answer in terms of x, right? So you put sine x to where u is. So you have sine squared x divided by 2 minus 2 sine to the 4th x divided by 4, which this guy right here will cancel this guy 2 times, so like that, plus sine 6x divided by 6 plus c. So your final step, just writing it up, over 2 minus sine of 4x over 2 plus sine 6x over 6 plus c. So this is our final answer. We have actually integrated this problem right here. We took advantage of the fact that cosine here has an odd power, and which is greater than 1, and we use the rule where we split one of the powers and substitute. So if you like this video, go ahead and hit the like button. I'm going to work a lot of examples on cosine and secant and tangent. So I'll see you in my next video. Have a nice day. Bye.